Welcome to mathematics class, matrices part 14. So in continuation with the last class, we are dealing with solving the system of simultaneous equations by using matrix inversion method. So in continuation, let us solve some more problems in this method so that you will be familiar. So you will have a clear idea about this method. In the last class, we did 2 problems. So now let us take up one more from the exercise. That is 5th problem. 2x minus y plus 3z is equal to 9. X plus y plus z is equal to 6. X minus y plus z is equal to 2 is the system of simultaneous equations. Solve this system of equations by using matrix inversion method. Matrika viloma paddhati ద్వారా ఈ సమీకరణ వ్యవస్థకు సాధన కనుక్కోవాలి. Let us first convert this equations into matrix equation. Algebraic equations into matrix form. The first one, coefficients of x, y, z in all the 3 equations will be the first matrix, that is A coefficient matrix. And x, y, z is the variable matrix. Let us call it as capital X. And 962, the constant matrix, let us call it as D. So A into X is equal to D is the matrix equation. This is called matrix equation. Now let us find the cofactors of A. So for this, the solution is X is equal to A inverse D. So in this method, to find solution, we need to find A inverse. That's why it is called inverse method. By using inverse matrix, we find the solution. So to find inverse matrix, we have to find adjoint. To find adjoint, we have to find cofactors. So now let us find the cofactors. Now, cofactors of R1, the first row elements, cofactor of 2, that is first element in R1. So for this, we know the procedure for cofactor of an element. So after removing the row and column in which the element lies, then take the remaining 4 elements. So this is the procedure to find cofactor. So రెండు కోఫాక్టర్ కావాలంటే రెండు ఉన్నటువంటి అడ్డు వరుసను నిలువు వరుసను మినహాయించి మిగతా 4 మూలకాలు తీసుకోవాలి. So removing the R1 and C1. So the 2 is in R1 and C1. So removing R1, C1, the remaining 4 elements 1, 1 minus 1, 1. And finding its determinant 2. So for this second element of first row, first element and third element of second row, second element of third row, the cofactor sign changes. So we have to multiply with minus. Already all these things explained in previous classes. So this is why this happens. This is minus 1 to the power I plus j. So for that purpose, we need to multiply with these 4 elements with minus. Minus vastundi, odd number of minus 1 power odd number రావడం వల్ల ఈ 4 elements cofactor కు minus multiply చేయాలి. So for -1, so remove R1 and C2, take the remaining elements 1 minus 1 1 1 1. For 3, R1 C3 remove cheste remaining 1 1 1 minus 1. So the determinant 2 0 minus 2 will be the cofactors of the first row elements. 2 cofactor 2 minus 1 cofactor 0, 3 cofactor minus 2. Similarly, cofactors of second row elements. So second row elements 1 1 1. So the first element 1, you remove R2 and C1, you take the remaining 4 elements. For second element of R2, you remove R2 and C2. రెండో అడ్డు వరుస రెండో నిలువు వరుస మినహాయించి మిగతా 4 తీసుకోవాలి. For third element of R2, you remove R2 and C3. మూడవ కాలంలో ఉంది కాబట్టి మూడవ కాలము రెండవ అడ్డు వరుస వదిలిపెడితే మిగతా 4 మూలకాలు తీసుకోవాలి. So like that, for first element -1 3 -1 1, we get -2 cofactor. And for second element 2 3 1 1, 2 minus 3 minus 1. For third element minus into 2 minus 1 1 minus 2. Remember, for R2 we have to multiply first element and second element with minus. In R1 only second element. In R3 only second element. Only in R2 we have to multiply 2 cofactors with minus. So like this, after finding the cofactors of R2, then R3 minus 4 1 3. So these are the cofactors. Every time eliminating the row and column in which the element lies and taking the remaining 4 elements and calculating the determinant will give us the cofactor. ఒక మూలకం యొక్క కోఫాక్టర్ కనుక్కోవడానికి ఆ మూలకము ఉన్నటువంటి అడ్డు వరుసను నిలువు వరుసను మినహాయించి మిగిలిన 4 మూలకాలతో మనం ఒక మాత్రిక నిర్ధారకాన్ని కనుక్కోవాలి. అదే దానికి కోఫాక్టర్ అవుతుంది, సహ గుణావయవం తెలుగులో. సో ఈ విధంగా ఆఫ్టర్ క్యాలిక్యులేటింగ్ ఆల్ the cofactors of 9 elements, now write the cofactor matrix. First row, second row, third row cofactors, and convert the rows into columns. So that is the adjoint matrix. Cofactors no transpose cheste vachedi adjoint matrix. So adjoint matrix is the transpose of the cofactor matrix. సో ఇక్కడ రో ఇక్కడ కాలం గా మార్చేస్తాం. సో ట్రాన్స్పోజింగ్ ద cofactor matrix, that is converting the rows into columns, will give us the adjoint matrix. So here adjoint matrix, writing the cofactors of first row as first column, second row as second column, third row as third column will be the adjoint matrix. So after calculating adjoint, now it is time to find the determinant. You can find the determinant in both ways, by direct calculation and by definition also. The definition is, the determinant is nothing but the sum of the product of the elements with their respective cofactors is the determinant of a matrix. So here element and its cofactor, if you take the sum of these products, that is the determinant. So in first row A1, B1, C1, small a1, small b1, small c1 are the first row elements. Capital A1, capital B1, capital C2 are the cofactors of first row elements. So element into its cofactor. So element into its cofactor, element into its cofactor, and taking the sum total of all this product, that is the determinant. So first element and its cofactor. ఇట్లా ఒక R1 లో తీసుకోవచ్చు, R2 లో కూడా తీసుకోవచ్చు, R3 లో కూడా తీసుకోవచ్చు, లేదా C1 C2 C3 కూడా తీసుకోవచ్చు. ఇది డిటర్మినెంట్ డెఫినేషన్. సో R1 లో తీసుకుంటూ ఉన్నాం మనం. 2 into its cofactor 2, -1 into its cofactor 0, 3 into its cofactor -2. So this is the determinant. So that gives us -2. Determinant is -2 and already adjoint matrix is there. So with this 2, we can write the inverse matrix. The inverse of A is the adjoint by determinant is the definition of inverse matrix. So adjoint matrix by determinant. By determinant is the number. Determinant is nothing but it is a value. It is a number, numerical value. So this denominator determinant can be written as 1 by the determinant. Instead of dividing the entire matrix with the determinant, it is easy to write the determinant just as side by the matrix as 1 by -2. Here -2 is the determinant. After finding A inverse, now the solution for this equation, system of equations is x is equal to A inverse D. Here A inverse is the inverse matrix and D is the constant matrix. So A inverse into D. A inverse into D. Here 962 is the constant matrix. Now multiply both. We know how to multiply rows into columns. Taking the rows of first matrix and multiplying with the column of second. So only one column is there. So only one multiplication, one row and one column. So R1 C1, R2 C1, R3 C1. So first R1 C1 will give first number, R2 C1 second number, R3 C1 third number. So R1 3 numbers multiply with C1 3 numbers. First number with first, second number with second, third number with third. Like that, after multiplying 3 rows with C1, 2 into 9, 2 into 6, 4 into 2. So we get 18 minus 12 minus 8, 0 minus 6 plus 2, minus 18 plus 6 plus 6. Okay, this is minus 20 plus 18 minus 2, minus 6 plus 2 minus 4, minus 18 plus 12 minus 6. So minus 2, minus 4, minus 6. Divide all these three elements by determinant minus 2. Divide first element with minus 2, second element with minus 2, third also minus 2. So that will give us 1, 2, 3 values. So that is the matrix X, and X is nothing but the variable matrix X, Y, Z. So the solution, the values of X, Y, Z, X is equal to 1, Y is equal to 2, Z is equal to 3. You can check the answer by substituting these values in one of the given equations. So now let us consider one more problem. This is 7th problem from the exercise. 2x minus y plus 3z is equal to 8. Minus x plus 2y plus z is equal to 4. 3x plus y minus 4z is equal to 0. Solve this system of equations by matrix inversion method. First step, convert them into matrix form. The first matrix is coefficient matrix. Coefficients of x, y, z in all the three equations will be the first matrix A, and x, y, z is the variable matrix X. 840 is the constant matrix, that is, let us name it as D. So this Ax is equal to D is the matrix equation. So first, the coefficient matrix A. So let us consider this as A1, B1, C1, A2, B2, C2, A3, B3, C3. So the cofactors of all these elements, the cofactor of small a1 will be capital A1, cofactor of small b1, capital B1, cofactor of small c1, capital C1, and in second row, small a2 cofactor capital A2, small b2 cofactor capital B2, small c2, like that. The small a1, b1, c1, a2, b2, c2, a3, b3, c3 are the elements, and the capital A1, b1, c1 are its cofactors respectively. So now in first row, cofactor of first element 2, that is A1, let it be as capital A1. So the same procedure. So 2 lies in R1 and C1. So eliminating R1, C1, remaining 4 elements, 2, 1, 1, 4. Minus 1 lies R1, C2. So eliminating R1 and C2, remaining 4 elements, minus 1, 1, 3, 4. And 3 lies in R1 and C3, third column. So eliminating R1, C3, remaining 4 elements. Like that, for R2 also, for first element minus 1 lies in R2 and C1. So eliminate R2, C1 and take the remaining 4. For the middle element 2, this middle element 2 lies in R2 and C2, second row and second column. So eliminating second row, second column, take the remaining corner 4 elements. So for the last element in R2, this lies in R2 and C3. రెండో అడ్డు వరుస మూడవ నిలువు వరుసలో ఉన్నది కాబట్టి అవి వదిలిపెట్టిన తర్వాత take the remaining 2 minus 1, 3, 1. In R3 also, the 3 first element lies in R3 and C1. So eliminate this and take the remaining. So the second one lies R3 and C2. Eliminate R3, C2 and take the remaining 4. So minus 4 lies in R3 and C3. So eliminate them and take the remaining. This is how we select the 4 numbers, eliminating the row and column in which the element lies. So this is how we select the 4 numbers. So don't get confused. If you take the wrong number, the entire thing will go wrong. So selecting the numbers, 4 numbers, you should be more cautious while selecting these numbers. Otherwise, your entire effort will be in waste. So be careful that selecting the 4 numbers. Once again, you check it twice, thrice. So after confirming, then proceed. So numbers wrong select cheste manam chesedanta waste avutundi. And don't forget that multiplying with minus for these 4 cofactors. So keeping all these things in your mind, taking all precautions and selecting the correct 4 numbers, then the simplification will be very easy. And the determinant AD minus BC, it will give minus 9, and second one minus 1, for third C1 minus 7. In R2, minus 1, minus 17, minus 5 cofactors. In R3, the cofactors of 3, minus 7, 1, minus 5, minus 4, 3. After finding all the 9 cofactors of R1, R2, R3, then write them as a matrix, cofactor matrix of A. So let us call it as B. So B is the cofactor matrix of A. So writing the cofactors of first row, cofactors of second row, cofactors of third row. So this is the cofactor matrix. So converting the cofactor matrix, the rows into columns. So that is the transpose of this cofactor matrix is the adjoint matrix. ఈ B యొక్క వ్యత్యయ మాత్రికనే ఇక్కడ అనుబంధ మాత్రిక అవుతుంది. కాబట్టి Bని వ్యత్యయం చేస్తే అనుబంధ మాత్రిక వస్తుంది. Convert, if you take the transpose of B, you will get adjoint. So what is transpose? Converting the rows into columns. Very easy. ఇక్కడ rows ను columns గా రాస్తే అది transpose అవుతుంది, అదే adjoint. So follow the procedure. So transpose is nothing but converting the rows into columns. ఇక్కడ అడ్డము ఉన్నవి ఇక్కడ నిలువు రాస్తాం అంతే. వెరీ ఈజీ. ఏం క్యాలిక్యులేషన్స్ అవసరం లేదు. So after that, then we need to find determinant. So determinant element multiply with cofactor. You take any three elements of any row or any column and multiply with their cofactors and take the sum. That is the determinant. So we are taking first row elements and multiplying them with their cofactors and taking the sum. So first row elements 2 minus 1 3. So 2 cofactor minus 9, minus 1 cofactor minus 1, 3 cofactor minus 7. So element దాని cofactor ను multiply చేసి అవన్నీ ప్లస్ చేస్తే వచ్చేదే డిటర్మినెంట్. ఇట్లా చేయొచ్చు, లేదా మన ప్రీవియస్ ప్రాబ్లమ్స్ లో మనం డైరెక్ట్ గా చేసే పద్ధతిలో కూడా మీరు డిటర్మినెంట్ కనుక్కోవచ్చు. సో I did in the first problem, I did with normal procedure, and from the second I did with this definition. రెండు విధాలుగా చేసి మనం చూపిస్తూ ఉన్నాం, so that you can don't get confused. You can find there are two methods to find determinant. Okay, after finding determinant, now write its inverse. That is A inverse is equal to adjoint by det. So adjoint and by det, the denominator of determinant is nothing but it is a number minus 38. So it can be written as 1 by minus 38. So this is the 1 by minus 38 into this. This is the inverse matrix of A. And the solution x, the solution will be x is equal to A inverse D. A inverse and multiply with D. So D is the constant matrix. So multiplying this A inverse with D. So write A inverse and write D. Multiply them. R1 with C1, R2 with C1, R3 with C1. So first R1 3 numbers, C1 3 numbers, first number into first number, second number into second number, third number into third number. And then take the 3 numbers of second row and multiply similar way, and take the third row 3 numbers and multiply the 3 numbers of C1. After multiplying and simplifying, you get minus 76, minus 76, minus 76. All are equal in this problem. So this 1 by minus 38, if you bring inside this by minus 36 belongs to all the three numbers. So you divide this with minus 38. You divide all the three numbers with minus 38. So minus will get cancelled. 38 1 ja, 38 2 ja, 76. So dividing we get 2 2 2. So this is the solution, the variable matrix XYZ. So the X value is 2, Y value 2, Z value 2. So we did 4 problems in this method. you practice some more problems from the exercise, and from the textbook. They are already solved problems are there in the textbook. You can practice. You can practice simultaneously. You take one problem and try to solve it in Kramer's method, and you can solve the same problem by using matrix inversion method. So whatever the method it may be, the solution should be the same. So ఏ మెథడ్ లో చేసిన సొల్యూషన్ ఒకటే రావాలి. You remember one thing. In exam they ask to solve in a particular method. If they ask to solve in Kramer's rule, you have to solve in Kramer's rule only. If they ask Kramer and if you do inversion, simply they strike it off. So be careful. ఏ మెథడ్ లో చేయమంటే అదే మెథడ్ లో మనం చేయాలి. So you should be perfect in all the three methods. If examiner in exam they may ask to solve in matrix inversion method, they may ask to solve in Gauss-Jordan method. So if you don't know Gauss-Jordan, though if you know Kramer's, so if you want to solve it in Kramer, they don't give marks. It is not valid. So you should be perfect in all the three methods. So you should be able to find the solution in all the three methods which are there in intermediate level. So that we have covered two methods, Kramer's and matrix inversion method. So in next class, we will deal with the Gauss-Jordan method. So already it is almost similar to the previous problems which we did in consistency and inconsistency. Almost we did the Gauss-Jordan method in that consistent and inconsistent problems. So anyhow, we deal that method in next class. So with this, I want to conclude today's this class. So you keep practicing more problems from the exercise and example. Prepare your notes. More practice, more perfect. Practice makes man perfect, don't forget. So mathematics is nothing but a practicing. So thank you for watching this.